Hi everyone, I hope everyone is fine. So today we are going to discuss one question, which is the amount of the time for binary tree to be infected. So basically, this is a question 2385 on Leetcode, and in this question, the description is as follows: You are given the root of a binary tree with unique values and an integer start. At minute zero, an infection starts from the node with value start, and each minute a node becomes infected if the node is currently uninfected and the node is adjacent to an infected node. So return the number of minutes needed for the entire tree to be infected. Okay. So basically, in this example, as you can see here, this is a binary tree data structure, and in this data structure, there's a point 3. So this is the starting point of the infection. So when the infection spreads, so it is going to transfer the infection from one place to another, like one point to another. So this 3, when it is going to be infected, it is going to pass the infection to all of the nodes which are attached to it. So this 3 will pass the infection to this 10 node and this 6 node and the 1 node. In this case, 1 is the parent of 3 and 10 and 6 are the children nodes of 3. So this is actually the question. So the problem with this question is that first for this one intuition is that we are going to like traverse from the all places, like for from 3 to 1 and from 3 to 10 and 6. But in case of binary tree, what happens is that you can traverse from only parents to children. Okay. So 1 to 3 and 1 to 5 is the traversal which is possible. But in case if you want to like traverse from 3 to 1 or like 5 to 1, then it is not possible because it is opposite to the direction it actually follows in a binary tree. Okay. So the logic which we are going to do is the intuition which we are going to use is that it is converted into the graph in such a graph that the traversal is possible from all the sides. Like the traversal is possible from 3 to its 1, 10, and 6. Like for all the directions, the traversal will be possible. Okay. So basically, I have written this function here. Okay. So make a function for traversing the parent. So this function, what actually this does is first, for all the nodes like 10, 6, 3, 1, and 5, it is going to store the parent. So if we store the parent, if we mark the parent of a particular node, then we can traverse to its parent. Okay, so we can check who's the parent of which node. For example, if we take in consideration this 3, which is the infection point, so the parent of this 3 node is actually 1, and similarly for the parent of the this 5 node is actually 1. Okay, so this is the work of this function. Okay, so what we'll actually do is in the argument, as you can see, this root is passed, the start is passed, and the map data structure which we are going to take in order to mark the parents. Okay, so first make a queue of the type tree node. So we are going to store tree nodes inside of our queue, that is why we are declaring this queue with tree node data type. Okay, so now after that, inside of the queue offer the root, which means pushing the root inside of our queue. Okay, so this one is actually the root which is going to be pushed inside of the queue. Now we are going to declare a tree node start node, and we are going to assign the value as null. Okay, I hope this is clear up to this point. And then we are going to traverse the queue until it is empty. Okay, so the first one is the this one which is the root which is going to be passed. And similarly for this while loop, what it actually does, inside of the while loop we are checking for these three if statements. So basically we are first going to, the most important point is to find the point where the infection actually starts. Okay, so this if current dot value, if the current value comes out to be the start value, then we are going to like assign the start node equal to current. Okay, the start node is actually null here, as you can see. So first we are going to find out like which is the starting point of the infection. Okay, for and this function what it actually does is to mark the parents of all the functions. So in the below if statements, it is going to check for the left and the right subchildren of every node. So for example, if we take in consideration is this 3. Okay, so for this third node, the for this 10th node, sorry, for this 10th node, we are seeing that this 3 is actually the parent of this 10 node, and for 6 also the 3 is the parent node. That is how this parent map data structure, which is a like map data structure, is going to map. Like for this 10, 3 is the parent, and for this 6 also 3 is the parent. Similarly for all nodes we are going to mark the parents. For this 5, 1 is the parent. For this 4, 5 is the parent. For this 9 and 2, 4 are the parents. And that's how it actually works. So it actually helps to traverse in all the direction, or check in all of the direction, like who is the parent of which node. Okay, so that is the work of these three if statements. And then after we are marked the parents of each of the nodes, we are going to just return this start node, which is actually the infection point. Okay, so this is the point where the infection start. I hope everyone is clear. So now let's take this is another function. This is the main function. Okay, so in this main function we are actually passing the root and the start. So first we are going to declare a map data structure, and map data parent map. Okay, so this parent map is like passed as an argument to this function, as you see. So this is going to mark the parents, okay, inside of that parent map. And also I have forgotten one thing, that it is also pushed off inside of the queue, currents left and currents right. Okay, so now first the we are going to find the infection point. So this 3 is the infection point or the infection node. Okay, so tree node start node equal to build parent map. We are going to pass the root, we are going to pass the start point, and we are going to pass the parent map. And this function after processing gives us the starting node or the starting point of the infection. So now we are going to use the BFS traversals. So for this BFS traversal, we are going to use two data structures, queue and hash set. Okay, in order to mark the visited elements. I will tell you what is going to happen now. So this queue and the visited queue and hash data structure are declared here. And after that, what will we actually do? So we are going to just since we have already gotten the start node. Okay, so this is the point where the infection is going to start, so we are going to just put this inside of our queue. Okay, so this will be the first point, and we are going to mark this as visited. Since 3 is like visited, we are going to start from this point now. So for that case we are going to mark this as visited, and we are going to declare a time variable, and we are going to assign this value of -1. Now what we are going to actually do is we are going to run a while loop. So since this is inside of our queue data structure, and it is also marked as visited inside of our hash set. Okay, so now we are going to empty the queue. So in this case, as you can see, we are going to increment the value of time by 1, since we are going to first traversal. Okay, and first we will going to check the size of the queue. For first case, what will happen? As you can see, this 3 node is actually the starting point, and for this one we have this 1. Okay, the size of the queue is currently 1, and for this size we are going to just extract this out of the queue, and we are going to check. Okay, we are going to check, like if the current, like this for this current, the left child is not null and it exists, and the right child if it is not null, and if it exists. Okay, so if it is not visited, like for the example, if it is not visited, we are going to put this inside of our queue for further traversal, and we are going to mark this as visited. Okay, so this one is visited now, and for this 6 is also the visited. So the left and the right child of this 3, which is the like parent node of this one, so it is going to mark this like it is visited and it is burnt, it is infected. And this this tree also, like for this subtree also, right subtree, this right subnode is going to be visited and it is going to be infected. Now similarly, the parent of this third node, like this infected node, is 1. So as we have marked all the parent nodes for it in the below previous function, we are going to use that logic here. Okay, so we are going to use the benefit of that, and we are also going to mark this one as visited, and we are going to put this inside of our queue for further processing. And then since we are traversing for one time, like we have already traversed from one time, we are going to increase the value of -1 to 0. Similarly, if you do for all of these, like since this 10 and 6 is already put inside of the queue, we are going to check for the second time. Same process we are going to repeat for all the nodes. Okay, and at the last, as you can see, -4 comes. Try to dry run this on the copy and pen to understand it better. So the basic logic is this. For like the logic which I have already explained for this infected node, so this is going to apply for all the nodes here, and after processing all the nodes, the value comes to be 4. Okay, I hope everyone can understand this. If you have any doubt, please ask me in the comment section, and I am happy to take a feedback. Thanks.